So, exponential equations. Yep. So when we're talking about logarithms, we're still going to go through the same basic idea of solving for x. But in this case, it's going to be, instead of using exponent rules, we're using log rules. Okay? Log rules! Kind of like a tutorial. What do you do first?
Math. See, you missed me. Wow.
Joy's not here today.
21 minus 4 is?
Yes.
Now, remember the properties of logarithms. There are two main properties of logarithms that we have to worry about. B, the log base b of x is x. And log base b of b to the x is also x. When these values are the same, these drop. Okay? So I have to do what to get that variable out? Log, right? I can say log base 10, but that's just way too precious time. We log it. So we have 2x minus 3 is the log of 17. And now to get x by itself, it's like dealing with a linear equation. All you need to worry about is add 3, divide by 2. So your value of x in exact form, if you will, is log 17 plus 3 over 2. Whatever that decimal works out to be. Log equations, we usually use the calculator the rest of the way out. Log equations, you can usually use the calculator the rest of the way. The exponentials, I like to give you guys exponentials without calculator, because they're not terrible. Log ones, I'll let you have the calculator, so I'll say around 100. Yes, sir? Read instructions. Remember when you had log, I think it's in the x rule. Then you, yep. You shouldn't get error. Guys, hey. Guys, enough. Log is 17, hit the log button. 17, hit enter. Plus 3, hit enter. Divide by 2, hit enter. There's your answer. 216, or 212, excuse me. That's all you're doing. You don't have to do the log alpha window 5. You just hit the log button because it's base 10. You do alpha window 5, you have to put a 10 there for the base. Okay. Think about what we did yesterday. Yes, ma'am.
So if we leave it at absolute, though, it'll be fine.
Read the instructions will tell you what to do. Okay? Think about what we did yesterday. Yesterday we talked about exponential functions. If you had anything that was b to the x and it equaled b to the y, since those two bases were the same, what were we able to do with whatever their exponents were? They set equal to each other. The reason that we were able to do that was because in the background, what we did is we took the log base b of both sides. Because when you take the log base of the same thing on both sides of an equation, these drop. Well, today, it's going the other way. Today, technically, if I go 3 here, 3 here, since those are both the same log bases on both sides, the logs drop. And you get that. So if you wind up with logarithms of the same base on both sides of an equation, they basically undo one another because you could show exponentiation. You don't have to, because the property says if you have the same log base on both sides of an equation, the junk are equal. Okay? The rule will say that. Just like it did yesterday. Just like it did yesterday, if I had b to the x equals b to the y, then we know that x equals y. So if you get log base b of x equaling log base b of y, again, x equals y. It works the same way, because you could exponentiate. What's up?
Could you even solve it if the spaces weren't the same?
Well, we're not gonna worry about it.
For now.
I will. So now you have variables on both sides. It's real quick. You get 4x equals 8. X is log equations. I want you guys to get in the habit of always checking your answers with log equations. Log equations, there's always the possibility that something could go wrong. Not so much all the time with exponentials, because those are pretty straightforward. But when you're dealing with logarithms, something could happen. So real quick, what's 5 times 2? What's 10 minus 1? So you have log base 3 of 9, okay? What's 2 plus 7? Log base 3 of 9. What is the log base 3 of 9? 2. Does 2 equal 2?
Yeah, maybe.
Sometimes. Maybe tomorrow. Okay? Yeah. Uh-oh. Uh-oh, more steps are showing up now. He's not happy. So you have log base 2 of the quantity x plus 2 equals log base 2 of x squared. Now, in this case, do you have the same log base on both sides? Yes. So the logs go away, and you get x plus 2 equals x squared. Which means you have to set one side equal to 0 and factor. What times what is -2? You add together to get -1. Okay? What are your zeros? 2 and -1. Check your answers. And this is why you have to write it out. You can't just say it's 2. Right? You're only half right. Because sometimes when you get these, you're going to get a negative answer that could possibly work. So what's 2 plus 2?
4.
Okay. Log base 2 of 4, does it equal log base 2 of 4?
Yeah.
Okay. What's -2 plus 1? 1. Thank you. That took a while. I know it's hard, but you can do it. And what's -1 squared? It is also 1. Proud of you. That was quicker. So does the log base 2 of 1 equal the log base 2 of 1? Yes. So in this case, you have 2 possible solutions. Yes, ma'am?
If it ends up being like log 2 of -1, then it would like it would.
Then it won't work because you can't take the log of a negative number.
Right.
And that's where that's where I want you guys to see that you can't have a negative number that will work.
All right.
I think you did that last year in circles. You remember how you had you did a lot of quadratics with secant tangents and stuff like that in circles, where you had a spectrum stuff, where sometimes you had a negative value of x, but you're like, oh wait, I can't have a negative segment, but if you substitute in, it became positive. So it's the same kind of idea. Okay? What happens when you don't have oops.
It's interesting.
Cry.
No. If you only have one log, we have log base 5 of 3x plus 1 equals 2. Right. This is the example of where exponentiating is really a thing. The term exponentiating came from the textbook. I wasn't totally crazy. I knew it was a real word. It was printed somewhere. So go back to your properties. How do I undo that log base 5? I exponentiate with a base of 5. So then I get 3x plus 1 equals 5 squared, otherwise known as 25. Okay. There you're back to a quick linear equation. Nothing too fancy. Subtract 1, divide by 3, and you get 8. So go back and check it again. 3 times 8 is, plus 1 is, so log base 5 of 25, well, 25 is 5 squared, which means we go back to using all of your rules of simplifying logs of checking your answer. So it does work. Okay. You'll need a calculator for that. You don't know. And that's what's good. I got a good couple questions here to show you guys. I'm going to start with the basics. Log base 2 of x equals -1.
I don't know what I'm talking about.
Apparently.
No, x equals a half.
So if you do it, you get 1/2. Okay. Don't worry, it's not always this easy. Okay. What is log base 2 of 2 to the -1? Shut up. Were your teachers at your old school this belligerent? Shut up.
Are you at your old school use vocabulary that big? I feel sorry for you.
I've used 2 big words today, exponentiating and belligerent. I'm well above my syllables level. Yes. I knew that. He knows it. What do you do first? 15. Hello.
Oh my.
Now what? What's that? Can I do that yet? What do I do? What were you thinking? The x squared? Well, are you wrong? Now, what do you have to do now? Not times by 2, exponentiate it by 2. So 2 to the 8th power is, well, 5 is 32, 6 is 34, or 64, 7 is 128, 256?
Yep.
Now, if you did it your way, what do we get then? You 2 it. I don't know what that is. So x squared is 2 to the 16th. And then if you think about it, that's taking it to the half power. which is 16 to the half is 2 to the. Are you wrong by going that route?
There's a lot.
No. Because you can manipulate, and when you're working with logarithms, guys, when you're working with logarithms, the properties come around all the time. What Joyce was thinking about doing there, excuse me, is by moving that 2 to become the exponent of the variable. That's perfectly fine if you want to do that. Or think of it as a constant out in front of the log, you just divide it. It works the same way. It'll work that way if it's an exponential equation. It'll work that way if it's a natural log. It works with logs. It does all the same. Just move it. It's quicker to move it than worry about exponent. Making it an exponent. Okay.
Why do you do this to us? Wait, no, that's not that hard actually.
Here's where properties come back. Here's where properties are going to come back into make this work. What happens is, in order for us to be able to exponentiate, log, whatever, in order for us to be able to do that, we have to have a singular log on one side to make it work. Well, right now I have log 5x plus log of the quantity x minus 1. I have to condense it before it. So when I condense logarithms, when I have addition between the two, what am I doing? I'm multiplying. Yeah, I'm going to write it as the log of 5x times x minus 1 is 2. Okay? Which means it's log of 5x squared minus 5x is 2. And if you want to do that first, instead of writing out that intermediate step, that's fine. But you're going to see a lot of this having to condense a log equations prior to do anything. Yes, ma'am?
Like, we can only do that though because like it's like log base 10, but like if it was like log 2, 5x, log 3, x minus 1.
You can't. You have to do the same things. Now I exponentiate, right, I 10 it. So I get 5x squared minus 5x equals 10 squared, otherwise known as 100. Which means I'm back to a factoring problem. 5x squared minus 5x minus 100. What is the first rule of factoring?
GCF.
GCF. Take out the GCF.
Basically just get rid of this 5 side. Yeah.
Does the 5 have anything to do with the problem the rest of the way through? No. What times what's negative 20? You add together to get negative 1. Which gives you possible zeros at? Which means that, excuse me, I go all the way back to the beginning. Can I take the log of a negative number? Nope. So this case here, 5 times negative 4 gives me negative 20. I can't take the log of a negative, so that's extraneous. It's an answer, but it's not an answer. Correct. Okay. So it is an extraneous solution. Happens a lot with equations that deal with logs. Okay.
Yes.
Yes. So it's x. He said k, and I said no, it's x.
But why did you say that?
46,000 square.
Yeah, nerd. You nerd.
That logic would be fantastic. I could bring this first. Okay. You do not need to.
Alright, I want to show you a scary one, so I want to do this quickly. Oh yeah, you're going to love it. No, you won't.
No, -5 doesn't work. That's negative.
7
Oh.
to negative 5.
Yeah. So you have x squared minus 2x.
It's funny if you're 16.
You get 7s and negative 5s. What do you throw out right away? Throw out the negative 5, and then from there, can I take a log of a negative? What's up?
Yeah, so if you took like, it was like log, and you got an answer as like 5, and you threw negative 5 back in there, but it was like, x plus like 10, would you still be able to use that negative?
Yeah, because then it's a negative that would work as a solution. I think we had that earlier where the negative 2 or the first example was. Sometimes a negative, sometimes it doesn't, by being negative doesn't preclude it from working.
Except if you throw it at anyone and it's like, and it comes out as a negative once you like add it together.
Yeah,
That's
then
what
you-
you throw it.
Sayonara, sucker.
That's not bad.
Sorry. I like this one a lot. Pay no attention to that vertical upright. It's just what got snapped into it. It's a llama. It is log base 2 of x plus the log base 2 of the quantity x minus 2. Yes, minus the log base 2 of the quantity x minus 3 equals 3. So this is going to combine a bunch of the properties. Excuse me. This is going to work with the properties of condensing logarithms. You have all 3 of those logs are of the same base. So when you have addition, what are you doing as you condense them? And then when you have subtraction, what are you doing? Dividing. So basically what happens here is as you condense it into this. Log base 2 of x times x minus 2 over x minus 3 equals 3.
So you want to do multiplication from where you should.
From left, it's PEMDAS. You're just going from left to right. So now, how do you undo the log? Exceeding by the 2, good. What's 2 cubed?
Someone say 6. Thank you. Someone say 6. I'm going to say 5 and then go back and say 6.
And then you're going to cross
Happy New Year.
multiply. Then you wind up with fraction equal fraction, which means you cross multiply. Since this becomes cross multiply it out. X squared minus 2x minus 8x plus 24 is 0. All I did there was, as I distributed the 8s, I just brought it back to the left-hand side because we're going to have to do that eventually anyway. Okay? So you wind up with x squared minus 10x plus 24, and you get x minus 6, x minus 4, zeros at 6 and 4. And then you check them. Okay, see what's up. Did I lose you when I brought this over?
Yeah.
Remember, this is just 8x minus 24, and I just subtracted over right away. I knew I was going to have to set it equal to 0. I just skipped this step. I'm getting lazy in my old age. I know. It happens. I have back pain.
I'm talking about myself.
Sorry to hear that you are old and you have back pain.
Yeah.
That's what I was thinking.
Yeah.
All of those?
Yeah. And really, most of them you're going to fly right through. There's only a couple of them that you have to worry about condensing and going through. Yeah, by all means, if you want to take a picture of that, go ahead. That's cool. Hey, see what's up. It's just the next page. What's that? Yeah. What's up? Oh, let me do this real quick. Before I get to you real fast, I want to show you guys. There's a question on here that people have asked earlier. Take a look at 52 real quick. I want to walk you through 52.
Which chapter is this?
It's the same section as yesterday. Slate 6. Page after yesterday. I want to walk you through how to set up 52 because there may or may not be another one like this. So, natural log stands for what? The log of the natural. Thanks. It stands for log base e. Okay. Which means if I have log base e of x plus log base e of x plus 3, I can condense it and write it, well, not exponentially, I'm going to condense it first. So then I get the natural log of x squared plus 3x. I just multiplied and distributed it out right away. Okay? Equals 1. Which means I have to just eat it. E to the 1 is e.
Wait, so how do you solve that?
Set it equal to 0. What times what is negative e that you add together to get 3? To what? Exactly. Jeez. Wow.
What? Nothing. And you know what you're I don't think that's really necessary.
It is.
You can do either one.
Excuse me. On your calculator, thank you for reminding me of that, Nick. On your calculator, your E button. Your E button is to the left of 4. It's the second natural log. But watch what happens when you hit second natural log. It wants you to make an exponent, which means I'm going to use e to the what power? 1. That's like the big E. That's like times 10 to something or another.
Yeah, the divided.
Where is it?
Second divide. Oh, good, the answer is.
Oh, that's right. I forgot that was there. Yeah, you could also do that one too. The alpha divide, that works as well. Okay. I forgot that it was that the other E button is second division. Okay. Second division is just a regular E with no exponent. Okay. Just wanted to remind you that yes. Quadratic formula shows up, it rears its ugly head. What's that? Do what? No. You can.
So I'm guessing this isn't going to be a decimal. I got error.
Well, that meant that maybe one of your answers was negative. You take a square root of a negative. I haven't done the problem yet. You can figure it out. Okay. You're welcome. I'm here. Excuse me. Izzy, you had a question?
I got it now.
Very well. Be right back there, sir.